for my initial example from Newton's second law, you realize that this is where we got up to. And also, we learned that force is equal to mass times acceleration, and force is always the resultant or net force if the body is being acted upon by a number of forces. So I'm saying that if you have a question, okay, and let's say a body of mass 20 kg being acted upon by a force 50 Newton that is moving in the west, and a force 40 Newton that is moving in the east, what acceleration would the body move with at the end of the day? Okay, if the mass is 20 kg and it has the gravity is 9.8.
No, I got the first with this one.
What is the net force? What is the net force you had?
Next one.
See, the net force when bodies are moving in opposite direction, to get their net force is just what? 50 Newton minus 40 Newton. That is all. I told you that if you are moving in opposite direction, you subtract. So you get 10 Newton. If you get 10 Newton at the end of
Yes,
the
I
day,
got.
what do? You come and multiply the 10. Or what do you do to the 10 to get your acceleration? If you are saying F is equal to what? Mass times acceleration, it implies that your force now is equal to what? 10. The 10 you had after the subtraction, 50 minus 40, because they are moving in opposite direction. If they were moving in the same direction, we would have added them. It's equal to what? The mass, you know that it is 20. So it is the acceleration that you don't know. At the end of the day, after division, you realize that 10 divided by what? 10 divided by 20. What are you going to get?
0.5.
You see, so that is going to be your acceleration. That is going to be your acceleration. That is going to be your acceleration. And what is going to be the unit? What is going to be the unit? It's going
Then
to
it's MS.
shame on you. It's going to be meters per second squared. Meters per second squared. All right. All right. So you can see some examples over here. I believe we have solved all those examples. Even you have the slide over here. Okay. That is the scenario I'm just giving to you is the same as this solution over here. Okay. But I don't know, you were fumbling. You have to revise your notes. And I believe life is going to be much more easier. Do you have any question to ask before we proceed? Do you have any question to ask before we proceed?
Please, no.
You don't have any question. So can I ask you a question? Can I ask you a practical question now?
Yes.
Okay. So my question is that why does a heavier object accelerate less than a lighter one under the same force?
And that.
Why does a heavier object accelerate less than a lighter object under the same force?
Also, I'm moving different direction.
Come again.
Because when they're moving in different direction, they will do so.
Let's say that on an inclined plane, you have you have two inclined planes over here. And the inclined plane you're having over here, you have a body of mass, let's say 50 kg. This one, the mass is 50 kg. And this one, the mass is 30 kg. 30 kg. Okay. This one, the mass is 30 kg. So the 30 kg, they are all being trying to pull with what? Just 100 Newton. You are using 100 Newton to pull them. I hope all these things I'm writing, you are also finding a way to jot them somewhere. This is how online classes. So if you are not able to take advantage to be writing certain things, you see that you lose a lot. You have to be jotting down so many things. So you see, this one is 50 Newton. This one is also what? This one is 100 Newton. This one is also 100 Newton. Okay, but their masses are different. So I'm asking you that why is it that if the same force act on this body, at the end of the day, the one with 20 or let me say the one with 30 kg will come out faster than the 50 kg?
Because the force is
The force
because
is
the force is bigger than
the force is the same. The forces, these are the forces. Do you know the difference between the forces at all? The force, what is the force over 100 Newton? This one to the force is what? 100 Newton. The only difference is the mass. This one, the mass is 30, and this one, the mass is 50. Okay. So it implies that the 30 kg mass will come out faster than the hot 50 kg because uh, uh, the heavier you are, the longer time it takes for you to be able to what? Come out. Okay, it will take time. Or if you want to explain it mathematically, it means that because acceleration is inversely proportional to mass, because acceleration is what? Inversely proportional to mass, larger mass resists change in motion more strongly to the same force produce larger acceleration. Okay. I hope you are clear now, or you want me to now bring the question again and you get a whole concept of what I'm trying to put across. My scenario is that why that a heavier object accelerates less than a lighter one under the same force. So you see that I have just changed a theoretical question into what? A mathematical question over here. You see, so why does a heavier object accelerate? Okay, less. In the next, I move beside, I didn't away first one no, and moving 10
mm,
than second one. No. Okay. If they are being
mm,
acted upon by the same load. So you just tell them that because acceleration is inversely proportional to what? Mass. Okay. Acceleration is what? Inversely proportional
inversely proportional
to mass. How do you understand this statement? How do you understand this statement?
acceleration.
It means that as acceleration is increasing, the mass is what? Decreasing.
Decrease.
You see, that is why the first time I even met you, I taught you variation. Without variation, you will not understand the whole concept of physics. Okay. So that is happening because acceleration is inversely what? Proportional to mass. That is, if acceleration is increasing, then the mass is what? Decreasing.
Decrease.
Okay. Uh-huh.
Okay.
If the mass is increasing, then it means that acceleration will also what? Decrease. Will also what? Decrease. So what I've written over here, I've rather written directly proportional, but the real symbol should be what? Inversely what?
Inversely
Proportional. So
proportional.
yes, inversely proportional. Inversely proportional. Inversely proportional. Okay, let's proceed. So um we have a question over here. Kindly read the question out. Kindly read the question out.
The body accelerates at 0.8 meters per second upward or at acceleration of 0.8 meters per second in the direction of the 100 Newton force.
Read question. So you are not done. I say you should read the question. Question one.
Ah, a man on a bicycle of total mass of 60 kg has a velocity of 2 meters. 2 meters. He paddles faster for 5 seconds and the velocity increased to 4 meters. 4 meters. Calculate the average force produced.
They say they should calculate the average force produced. I hope so it's just this one, they just use substitution, they use the formula, and then if you fix everything into it, you are going to get the answer. But we've already discussed this ones already. Okay, so that is it. That is it. I wanted us to look at some practical examples. Before that, let me pause the video. All right. So I have a question for you. Okay. So I'm going to read a question out and then you write the question. Okay. I hope you are ready.
Yes.
Okay. So even before we read the question, now I'm going to intentionally ask you this question again. Um, why why is this phenomenon so? Why is this phenomenon so? Or let me say, why does a heavier object accelerate less than light one under the same force? Under the same force. Why?
Because
Uh-huh.
the lighter the mass, the faster it moves.
All right. All right. Thank you. And mathematically, how would you explain that? What you are saying mathematically, how can you put that in a mathematical form for someone who does not understand? You know that you can meet physicists from, let me say, Germany or physicists from Russia. Okay. And when you want to interrelate with them, some of them they don't understand the English you are using. So you have to speak physics. That is the language of physics. You understand me? Uh-huh.
Yes.
So how to speak physics, what you are saying, that is that we are saying that what? The mass, okay, is inversely proportional to the what? Acceleration. Okay. Or we can also say that acceleration is inversely proportional to the what? Mass.
Yes.
Okay. So the acceleration is what? Inversely what?
Yes.
Inversely
Proportional.
proportional. So let me clean this and put a proportional sign of inversely proportional to the mass. So this is the proportional sign. You see. So I hope you now get a whole concept. So
Yes.
a physicist, if you meet a physicist from Russia, when you speak some of this, or you meet a physicist from China, okay, you realize that if you are speaking your English to him, he may not understand. Okay. But if you're able to just answer him with just writing this alone, he will understand. Do you understand what I'm trying to insinuate?
Yes.
All right. So I want to read my question to you. And the question is, my question is, let's say a concrete block of mass, 50 kg. A concrete block of mass, a concrete block of mass, 50 kg. 50 kg is pushed with a force of 200 newton. So it is pushed with a force of what? 200 newton. 200 newton. On a construction site in Accra, ignoring friction. So you are saying that the friction, okay, friction, our friction is equal to what? 0. Okay. Ignoring friction, what is the acceleration? So acceleration is what they don't know now. That is what they are telling us to find. What is the acceleration? Please, you have my full question now.
Please, please consider from the construction site in Accra.
So I'm going to take it all over again. I'm saying that
Mhm.
a concrete block of mass, 50 kg, a concrete block of mass, 50 kg, is pushed with a force of 250 newton. So let me
Is
write.
that 200?
No, I want to change it to 250 newton. It's pushed with a force
Okay.
of 250 newton. It's pushed with a force of 250 newton on a construction site in Accra. So this is the same as the force in a construction site in Accra. in a construction site in Accra. Ignoring friction, what is the force or what is its acceleration? What is its acceleration? So how will you simplify this problem for me? How will you simplify this problem for me? It's as simple as that. In our solution, because we are still on Newton's second law, you don't have to think plenty. Okay. In Newton's second law of motion, what are we saying? We are saying that what force is equal to mass times acceleration. So if you come and look at this carefully, the person has given you mass. Now he has given you force, but he didn't give you acceleration. So what should you think? You just use the formula F is equal to what? Ma. Okay. So use the formula F is equal to ma. So you say that if what if F is equal to mass times what? Acceleration, then what does that imply? You realize that that implies that our acceleration can be written as what? Force over what? Mass. Do you believe this?
Yes.
Force over mass. So finally, what does that imply? That implies that we can now pick our acceleration and then we do substitution. We do substitution. So let's, from substitution, what are we going to get? From substitution, what are we going to get? The force is 250.
250.
And then the mass is what?
50.
Come again?
50 kg.
Euro. So this is Newton and this is kg. So at the end of the day, your answer is going to be what? This zero will cancel this zero. 5 will go into 25. How many times? 5 times.
Right.
You realize that your answer is going to be left with what? Meters per what? Second squared. Why is that so? That is so because I told you that 1 Newton, okay? I told you that 1 Newton is the same as what? The same Newton is equal to mass times acceleration. So mass times what? And acceleration is equal to what? Meters per second what? Squared. In short, this can be written as what? Let's say meters per second what? Squared. But you know that the mass is also measured in what? The mass is measured in what? Hello?
Right. Kilogram.
Mass is measured in what? Newton is equal to ma. And mass is measured in what? Kg.
Kilogram.
Mass is measured in kilogram. And acceleration is measured in what? Meters per second squared. So at the end of the day, you realize that our unit for the Newton itself is what? Kg meters per second what? Squared. If you come and put that over here, kg meters per second squared. What is happening? At the end of the day, kg will take care of what? Kg. So you are left with meters per second squared. On this note, I still insist and still say that what? The laws of physics are the same for all observers in uniform motion relative to what? One another. Okay. Yes. So no matter how you apply them, you say that it works best. Okay. I want to give you a different one to see if you'll be able to solve, and you tell me the answer quick, then we move. Okay. The one we just solved, do you have any problem? Do you have
Please, no.
Okay. Because the first one I've taught you in person. That is why I don't want to waste my time on it. The first law. Okay. Yes. So this one, the second law, that was what we were on. So the given, I want to give you the question. I hope the first one you have the question and the full solution.
Yes.
Don't put your eye on the video because the video is a probability. I may send it to you or I may not send it to you. So if you don't write and the class is over, that is all for you. Okay, you won't get it anywhere again. So I'll urge you to write, jot down something at least. All right. So in the given, the question goes as what? A 10 kg bus, a 10 kg bus, a 10 kg bus is acted upon by two forces, 10 Newton to the right and 10 Newton to the left. Find the acceleration. So they say a 10 kg ball or a 10 kg box. So you can see that the kg is the hot mass. Okay. So it is what 10 kg. Or if in short, let me read the question out to you. Get the question one last more time and let me represent this mathematically. Okay. Okay. So I'm saying that a 10 kg bus is acted upon by two forces, 30 Newton to the right and 10 Newton to the left. Find the acceleration. Find the acceleration. Find the acceleration. Please, are you done?
Yes, please.
What is your answer for the acceleration?
Now I'm done writing the question. I'm now solving it.
Okay.
Yes, I'm done.
So what is the answer you had?
2 meters per second square.
And in which direction will it move in?
Nice.
Eh? Which direction will it move in?
To the right,
Why will it move to the right?
because we subtracted the left side from the right, so it's left is on the right.
Oh, my brother, just tell me that it will move to the right because the right force is the bigger one. That is all. Oh,
Okay.
if you, let me say, you have a force of the strength you're having is just 30 Newton and me, I'm having a strength of 70 Newton. Can you pull me? I'll pull you to
No.
my direction. Once I pull you, you should know that you are coming to my direction. So you should apply this and you see that it works in real life. It works in
Okay.
real life. What we say in and the kind of lifestyle we live in our daily life is what has been converted into physics, nothing else. Okay. Look at someone throwing a stone into the air. It has been converted into physics and we are solving it. Okay, so all these things are needed because before a plane take off, one day you may become a pilot. Okay, before a plane take off, they do calculations before the plane move. These are some of the reasons why they are teaching us some of these things. Okay, if you don't know some of all these things before, maybe you even go and read a pilot course. They say you should calculate the angle at which the plane is moving with. You won't be able to do. Okay, so you have to even be able to know this so that in the course of your study, if you want to divert to aerospace, you want to become a pilot, and you go and read such a course and you meet such questions, it doesn't become much of a problem because you have been taught before. Life become much more easier. All right. So this is the question basically. In our solution, you said you had what? 2.
Yeah.
Okay. Or how did you get?
2
Okay.
meters per
So
second.
the easiest way to solve this, our net force is, let's say F what? So the forces they gave us, I can say this one is I can call the first one. This one I can call it, let me say F2, and I'll call this F1. So I can say F2 minus what? F1 is equal to what? Mass times what? Acceleration. Good. At the end of the day, if I want to get my acceleration, what is my acceleration going to be? My acceleration is just going to be equal to what? Let's say A is equal to F2 minus F1, all into bracket over what? My mass. So by substitution, what does that imply? 30 minus 10. 30 minus what? 10.
10.
Always apply board mass. Board mass. Don't throw it away. Board mass. Even in the university, you still need it. Board mass. Let it be your key. Let it be your key. Yo. And the mass was 10 kg. So over here, 10. All these guys are in Newton. I could put a Newton over here. I could put a kg over here. Don't get confused. We said that what multiplication is commutative. So 1 times 2 is the same as what 2 times 1. As simple as that. At the end of the day, your A is equal to, at the end of the day, your A is equal to what? Your acceleration. So it's a vector quantity. That's why I'm putting the arrow on it. At the end of the day, we can say that our acceleration is equal to what? 20 Newton
Okay.
over what? 10
Newton.
kg. So finally, this is going to give us 2 meters per second squared. As simple as that. Do you have any question to ask? Do you have any question to ask even before we proceed? So you had it right, and that was a very nice.
Yes.
You have a question?
Please no.
You always don't have a question to ask. Why? Oh, okay. If you don't have questions to ask now, I'm expecting that even the next time I'll meet you, you should come and ask me some questions on some of the things we have learned initially. But if you come and meet me again and also what we've learned initially too, you didn't come and ask any question. Are you really Are you really with us? Are you really with us?
Yes.
You are sure?
Yes.
Okay. Let's look at this section and then we'll come back to this later. So let's talk about impulse. Okay. Let's talk about impulse. So I believe with the Newton's second law of motion, if you meet some questions like this again, you should be able to solve them. You shouldn't shake at all. You shouldn't shake at all. Let's begin with impulses. So you read. And for many times the link is going to go up. Maybe you have to come and re-click it to be able to what? Join again. To be able to
Okay.
again. So read and let's continue.
The impulse of a body is the change in momentum of the body. From Newton's second law of motion, force equals mv minus mu over time. F Ft equals mv minus mu. From the above equation, impulse of a body can also be defined as the product of force exerted on a body and the time it acts. Impulse into bracket I equals Ft, or I equals mv minus mu. The SI unit of impulse is Newton's second.
Kindly take it one last more time again. So relax. What they are just trying to say is that The impulse of a body is the change in momentum of the body. Is the change in momentum of the body. I believe you have seen change in momentum. Now you know what change in momentum is. Final
Yes.
momentum. What is the value of final momentum?
MV.
Good. So you see, if they say change in momentum, mv minus what? Or you can just say impulse. If you want to explain this scientifically to a Chinese man, you tell him that impulse I is equal to what? Is equal to what?
M
Change in what?
MV minus.
Change in momentum over what? Let me say time. So if you want to explain this mathematically to a Chinese man, you say that, or if you want to explain this, if you want to explain this, let me say mathematically, you are going to say that what impulse is the ratio of change in momentum to time taken. Where you see where you write change in what momentum is equal to what, and you simplify what it is, and t is equal to what, you simplify what it is, and then you state whatever function you are supposed to do. What I'm trying to say is that after putting the formula down, you explain the formula. That's all. Okay. You can also use this to, if you go into the examination when they ask you that, explain impulse, and maybe you have forgotten whatever you learned, you could write what impulse is equal to what. Let me say I is equal to mv minus mu. Okay. At the end of the day, all over t. So you can say that what where, and then you what, you underline it. Then you say that what mv is equal to, you tell him what mv is. You come and tell him what mu is also is. And you also come and write what t is equal. So in this case, what is our mv going to be? Where mv is equal to what? Final momentum. And mu is equal to what? Initial momentum. And t is equal to time taken. Is that not all?
Yes.
You see, that is why I always prefer formulas than definition. Okay, I always prefer formulas than this. With the formula, life is much more easier. So from the above equation of a body can also be defined as the product of force exerted on a body and the time it acts. Okay, impulse I is equal to what? Force times the time. Or impulse is equal to the change in momentum of the body. The SI unit of impulse is what?
Newton.
Newton seconds. Newton's seconds. That is the SI unit of impulse. Or yes, that is the SI unit of impulse. Okay. So the change in momentum, all of this is I. So mathematically, how can we write this? This can be written as what? I over what? T. Do you believe? Do you believe?